Number 3. Solve each of the following square root equations. For each, check to see if there are any extraneous solutions, show a work to support your answers, and circle your answers. If we take a look at this one here, then the key to solving square root equations is to make sure to isolate. And the good news on this particular problem is that the square root equation is already isolated. We've got a square root on one side, and we've got the 7 on the other. So when we start this problem, we're going to square both sides. Remember that square rooting and squaring cancel each other out, and we've got 3x minus 5. And over here, 7 squared is 7 times 7, which is 49. Looks like a familiar problem. But we're going to, oh, it's not exactly the same, but we're going to add 5 to both sides. And we get 3x equals 54 when we add both sides, add 5 to both sides. And then lastly, we're going to divide both sides by 3. And we end up, I believe, with 18. And then what we want to do is we want to check, because sometimes we get an extraneous solution. And this is what I've been doing to check. We're going to pull up our calculator, and we're going to type in our function, only instead of using x, we're going to put in the number 18, the answer that we just found. So we're going to go second square root, 3 times 18 minus 5. And what we want when we press enter here is set it better equals 7. So I'm lucky here because I have the calculator, so I can use this in here. I'm going to try to make it a little bit smaller to fit in the box. But that's what we're doing. We're typing our 18 back into the equation for x and making sure that it turns out to be what we're expecting it to be, which in this case is the 7. Let's try another one like that. Letter B. Well, same idea here. We want to solve this, but we need to isolate first. So we're going to subtract 1 on both sides. And sometimes people are afraid because you see the fraction in there, and it's not actually as bad as you might think it is, but 9 minus 1 is 8. And I didn't do super well. I'm going to rewrite this just a little bit better over here. But it's 2 times that square root. And really we want the square root by itself. That's the whole idea behind isolation. We're going to divide this side by 2, and we're going to divide this side by 2, and these 2's cancel out. So we have the square root of x over 3 equals 4. 8 divided by 2 is 4. And now that we have the square root isolated, then we can solve this problem. Because to undo square rooting, we square. They are inverse operations. Square rooting and squaring cancel each other out. So we're just left with x over 3. 4 squared, remember, is 4 times 4 is 16. Check on your calculator if you're unsure. This is in the calculator portion of the test. And how we solve something like this is we're going to multiply by 3. If we multiply the left side by 3, we multiply the right side by 3. We end up with x equals 48. But what we need to remember, especially on a test, is that we need to go back and check. Is our answer right? The nice thing is you can walk out of the room after taking a test and know, oh, I got that one right. We're going to take our calculator. We're going to go back in here, and we're going to use the problem, except that where we see the x, we're going to put in our value of 48. And I need to just do one more thing here. It's 2 times the square root. And then I can type in alpha y equals with my fraction button, if you have a modern calculator. And it's x divided by 3. And we just came up with our answer of 48 divided by 3. If I check my answer there, yep, 48 divided by 3. And then arrow out of that. So I'm using the right hand arrow, plus 1, because that's not, the plus 1 is not underneath the square root symbol. But when we press equals, we better come up with the number 9. And sure enough, we come up with the number 9. So there's our check of that problem. We typed it into the calculator, and it does match. 48 is our answer. If it didn't work out, then it would be considered extraneous. And at some point in time, we're going to come up with an extraneous solution. And but let's solve this one. And what I want to really stress to us is that we need to isolate. So our first step is going to be to subtract the 9 from both sides. When we do that, we're left with the square root of x minus 6 equals negative 6. Well, square roots, it is isolated, so we can square both sides. Square rooting and squaring cancel each other out, and we get x minus 6. Negative 6 squared is negative 6 times negative 6, which is positive 36. And then we add 6 to both sides. Come up with x equals 2. Again, as in part A, part B, and now part C, all of these answers look perfectly legitimate. But once we get that answer, we want to go back to our calculator and we want to check that. So we're going to put second square root to get our square root. Instead of x, we're going to put that value of 42 back into the problem, minus 6, and then right arrow out of that, plus 9, and we get 15. Well, as we look at this over here in our checking portion, the other side of the equation actually says 3, not 15. And because of that, this 42 is not a solution. If you have Mrs. Danhoff, she usually writes EXT for extraneous solution. And then you may remember that we've seen a symbol that looks like this, which stands for no solution. That's also an option there. So either write x doesn't equal 42, write extraneous, or write the symbol for no solution, or write no solution. You've got lots of options on that particular problem. Letter D. You recall that on the front page of our practice here, we practiced how to factor, and this one's going to involve some factoring eventually as well. And try to give yourself as much space as possible if you're following through and working through with the video right now. But what we're going to do is we're going to start by squaring both sides. And the nice part is that square rooting and squaring cancel each other out, and we get 2x squared minus 5x minus 12 equals 0. And we've got a squared in there, which ultimately means that we're probably going to have to factor, and we do. And in this particular case, we're going to have to split the middle, top it off, starting with taking 2 times 12 is 24. And the factors of 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6. And hopefully what you see is that 3 and 8 will combine to be 8 by subtraction. It's going to be positive 3 and negative 8 as we split the middle. We get 2x squared minus, plus 3x minus 8x minus 12. And we use the grouping here. We use greatest common factor as well when we have 4 terms from our split the middle process. And the greatest common factor is going to be x. And we get 2x plus 3. Greatest common factor in our second group is the 4, but watch out because it's really negative 4. Negative 8x divided by negative 4 is positive 2x. Negative 12 divided by negative 4 is positive 3. And we're close here. We do have to solve in this particular part of factoring. And then maybe, to make matters worse, we might even have an extraneous solution. But our factoring is 2x plus 3, and it's x minus 4. And we need to set each of those factors equal to 0 because we want to figure out what does x equal in this case. So we're going to take 2x plus 3 equals 0. Subtract 3 from both sides. We get 2x equals negative 3. Divide both sides by 2. And x equals negative 3 halves. Our other factor, x minus 4, is 0. All that we need to do is add 4 to both sides and we get x equals 4. So there's our two solutions there, but we need to go back and check. And by the way, if you prefer, this is x equals negative 1.5. It might make just a little bit easier method for us when we go to type it back into our calculator here, which is what we're going to do. Remember, we're looking at the original equation to type this in. So it's going to be second square root, and then it's going to be 2 times negative 1.5 squared minus 5 times negative 1.5 minus 12. And when we press enter, what we want to get is 0. So that worked out. Good. Let's try the other one. Our other answer was 4. So let's try that one. Same thing, second square root. So we're going to get 2 times 4 squared minus 5 times 4 minus 12. And it also equals 0. So both of these answers are solutions. By the way, it does say, if I remember correctly on the directions, to leave our answer in simplest fraction form. So we do want to say that the answer is negative 3 halves. The reason that I used the negative 1.5 is just to make it a little bit easier to type back into the calculator. To finish here on this particular problem, nice part is that our radical is already isolated, so that's helpful. So what we're going to do is we're going to square both sides. And we get x squared is 40 equals 49. Once again, when we see an x squared, we need to be thinking factoring. So we're going to subtract 49 from both sides. Then we get x squared minus 9 equals 0, which makes us think back to the front page when we had to factor. This is the difference between two squares. X and x. X times x is x squared. 3 times 3 is 9. Different signs. And again, there's many of you who can say x equals 3 and x equals negative 3. If you can't, this is coming from x minus 3 equals 0. We get x equals 3. And x plus 3 equals 0, and we're going to subtract 3 from both sides. Gives us x equals negative 3. And yet again, once we get to that point, we need to check our answers. And remember, we're going to put 3 back into the equation, check our work. And we're going to put negative 3 back in there and check our work. It's going to be second square root, and it's 3 squared plus 40. Well, that equals positive 7. If we look back at our paper, we see negative 7. 3 is not going to work. Let's try negative 3. Plus 40. Well, negative 3 also gives us positive 7. We need both of our answers to equal negative 7, and they don't. And because of that, again, you might say, doesn't equal 3, x doesn't equal negative 3. We can say no solution. Mrs. Danhoff writes extraneous ext by both. And you can use the symbol, I think it's that way, didn't do very well to write it, 0 with a line through it for the no solution. So there's lots of options for how you can write those answers.